Today we're going to look at one more example of a limiting reactant problem. We're going to be reacting 500 grams of silver nitrate with 192 grams worth of copper 2 chloride. Just like in the example up above that we were looking at with cookies, you can't just assume that because there's 192 grams of copper 2 chloride and 500 grams of silver nitrate that the copper 2 chloride is a limiting reactant. The only way you really know is by doing two different stoichiometry problems where you compare both of those reactants to the same product. We need to balance our reaction overall, so I would need a 2 in front of the silver nitrate and a 2 in front of the silver chloride. These are both 1s. It tells us up above that whichever chemical runs out first is your limiting reactant. So that's the chemical that's going to determine how much product you could make. The problem is we're not sure if that limiting reactant is the silver nitrate or the copper 2 chloride. So it suggests down below to look at how many grams of silver chloride could be produced if the silver nitrate was the limiting reactant. And we're going to do the same thing in number 2. How many grams of silver chloride could you make if the copper 2 chloride was a limiting reactant? When you're doing these problems, what you're going to do is compare both reactants to the same product and decide which one's the right answer and which one's the fake answer. So to do this, if we're going to pretend like the silver nitrates are limiting reactant, we're not sure yet which one's the limiting reactant. We have to convert those 500 grams of silver nitrate into moles of silver nitrate using the molar mass of silver nitrate. Once you're at moles of your original chemical, now we need to get to moles of silver chloride instead. So when we look up above from our balanced equation, it's a 2-to-2 ratio. Some people ask me if they can reduce that 2-to-2 ratio to a 1-to-1 ratio, and you absolutely can. Just be careful if you decide to stray from what the balanced chemical equation says, because sometimes I see people do things like they say that a 6-to-2 ratio is the same thing as a 3-to-2 ratio. They reduce one of them but not the other, so they make a silly math mistake when reducing. So you can reduce, just be careful if you do. Since this guy wants to know how many grams of silver chloride we could make, I need to go one more step and get those moles of silver chloride into grams of silver chloride. So this time I need the molar mass of silver chloride. Now a little bit of calculator work. We get to keep 4 sig figs because every mass that you see there has 4. After you throw that in your calculator, you would get 422.0 grams of silver chloride. Maybe. What we have to do next is see, what if the copper 2 chloride is the one that we run out of first? Do we really actually make 422 grams of silver chloride? Or do we run out of copper 2 chloride before we even hit that number? Let's find out. So we start with that 192 grams of copper 2 chloride, and just like above, we have to convert grams of copper 2 chloride to moles of copper 2 chloride using its molar mass. Now that you're at moles of copper 2 chloride, we need to use our balanced chemical equation so we could get from moles of copper 2 chloride to moles of silver chloride, the one we're comparing our reactant to. It's a 1-to-2 ratio, and just like above, we got to get those moles of silver chloride into grams of silver chloride using its molar mass. This one, after we throw this guy in our calculator, you get 409.4 grams of silver chloride. Step 3 tells us to compare the possible amounts of silver chloride formed, which case gives the real answer. Which one's the limiting reactant, the excess reactant. We learned during our limiting reactant demo that the smaller answer is always the right answer. So between 422 and 409.4, 409.4 is the real answer. 422 is fake. We never actually hit 422 grams worth of product because we run out of copper 2 chloride as soon as we hit 409.4 grams of silver chloride. So the real answer, we would be able to make 409.4 grams of silver chloride. So the chemical that's our limiting reactant, the one that limits how much product you could make, would be the copper 2 chloride. It's the chemical that we would run out of first. It's the one that limits how much product we can make. That by default then means that the silver nitrate is our excess reactant. The last problem here wants to know how many grams of the excess reactant are left over in the flask at the end of the reaction. The question is intentionally worded a little bit vaguely because if this was a quiz or test question, we wouldn't want to give it away which one was the limiting reactant, which one was the excess reactant. You might find it helpful to cross out the word excess reactant and replace it with whatever chemical name you're actually looking for. So since our excess reactant was silver nitrate, that's what I'd write there. Now it wants to know how many grams of silver nitrate are left over in the flask at the end of the reaction. So our goal is to get to grams of silver nitrate. That means we're not going to start with grams of silver nitrate. We're going to end with grams of silver nitrate. So what do we start with? You're going to start with the chemical that gives you the right answers. We found out up above that it's the copper 2 chloride that gives us the right answers, and it's the silver nitrate that's fake and does not give us the right answers. So we don't want to start with the 500 grams. We want to start with the 192 grams. That's the chemical that gives us the right answer. So I'm going to start with my 192 grams of copper 2 chloride. And all stoichiometric problems, you have to get those grams into moles. But what makes number 4 here different from number 2 that we did up above is that in number 2, we were trying to determine how much product could be formed. In number 4, we're trying to figure out how much excess reactant is left over in the flask. So the mole ratio that we're looking for in this problem is the ratio between copper 2 chloride and silver nitrate. So we need to go to our balanced equation up above and find the mole ratio here between, here's our silver nitrate, here's our copper 2 chloride. We're comparing one reactant to the other in this problem. Since I want my moles of copper 2 chloride to cancel out and go away, I'm going to put the 1 mole of copper 2 chloride on the bottom for every 2 moles worth of silver nitrate. And it wants grams of silver nitrate, so I need to take that one extra step and go from moles to grams using the molar mass of silver nitrate. With a little bit of calculator work, you'll get an answer of 485.1 grams of silver nitrate. But this isn't quite yet what the question was asking for. It wanted to know how many grams of silver nitrate would be left over when the reaction's done. But this problem here, this 485, it's not how much is left over. This is how much silver nitrate, this is how much reacts. Remember during our demo with the balloons, we had 3 different scenarios. One where the magnesium was the limiting reactant, one where the acid was the limiting reactant, and one where there isn't a limiting reactant or an excess reactant, that they both ran out at the same time. This 485.1 grams that we just found the perfect ratio amount. What that means is if you have 192 grams of copper 2 chloride, you need exactly 485.1 grams of silver nitrate to react with it, and then have both chemicals run out at the exact same time, which isn't quite what this question was asking for. So this amount is how much silver nitrate you need to complete the reaction. But how much silver nitrate did we have? When you look up at the beginning of the problem, we said that we have 500 grams of silver nitrate. But this problem tells us that only 485 of those are actually going to react. So to find out how much you have left over, you're going to take how much you have, which they'll tell you in the problem, that you have 500 grams of silver nitrate. And we're going to subtract out how much of that silver nitrate you actually need. And the difference between how much you have and how much you need would be the leftovers. 14.9 grams of silver nitrate would still be sitting at the bottom of your flask once the reaction finishes, just waiting to react. The problem is it ran out of copper 2 chloride and had nothing to react with.